All right, advent of code, day 3. Let's go. All right, submarine has been making odd creaking noises. You need to use the binary numbers in the diagnostic report to generate 2 binary numbers called gamma and epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit. Okay. In each position. Okay. Is the binary number here. Least common bit. Okay. Index accounts equals z hash dot new stirs dot each do stir stir dot cars dot each do with index do I index counts I plus equals 1 if ch equals 1. Total num equals stirs dot count. More, less. Stirs dot count dot length dot times do index if count equals index counts index if count is greater than index counts total num minus count else more less puts more puts less and then def to n binary dot reverse dot each dot with index do n and total equals 0 total size equals 1 total plus equals size if each if ch equals 1 puts to n of puts to n of more times 2 n of less. Cars. 22. All right. 360. Dang. Should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber. Holy cow. life support rating, which we determine by multiplying. All right, so oxygen and CO2. Similar process that involves filtering out values until only one remains. Consider just the first bit of those numbers. Keep only numbers selected by the bit criteria for the type of rating for which you are searching. If you only have one number left, stop. This is the rating value. Def filter nums criteria if you only have one number left, this is the rating value. Puts 2n Did I cheese it? Dang it. All right, I tried. Wait. Oh, okay. Yeah. Wow. Filter nums. Toggle. Puts filter 2n filter nums stirs true. Okay. Index equals 0. If nums at length equals 0, if there's 1. Okay. Num1 equal nums dot count s index equals 1. Num0 equals nums dot count minus num1. If bit if num1 is greater than num. So most common equals num1 is greater than num0. All right, let's do this. If num1 equals num0, else, then if toggle bit equals toggle 1. So if toggle is true, it's oxygen. If it's false, it's CO2. If toggle equals num1, okay, nums equals nums.filter s index equals bit filter nums toggle index plus 1. That looks rightish. Oh, all right, 182. Okay, it took away my time. That's annoying. All right, I'll hide that. All right, no leaderboard today. That's a bummer. But let's do this. Let's go back over this problem. All right, so binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers, which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate two binary numbers called the gamma rate and the epsilon rate. And the power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. So here's the example report. What's up, Sir Skull Legend? How you doing? Considering only the first bit of each number, there are 5 zeros and 7 ones. Since the most common bit is 1, the first bit in the gamma rate is 1. And then it continues on. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit is used. So the key thing is, oh, interesting. You don't even need to, the numbers will be inverses of each other. So you can just compute one of them and then like get the other one by subtracting from 2 to the number of digits. So this is 5 digits, so 2 to the n is 2 to the n minus 1. 2 to the 5 minus 1 is 31. So the sum of these will be all ones, which is 2 to the n minus 1. And so we see this is 22 and 9. But if we go back to my solution, we have this z hash, which is just a hash where the values default to 0. Then we loop over all the stirs over each character. we increment our counts if the character is 1. So then we build up, basically, because it's multiplication, it doesn't matter like which one is which. We can just do it both ways. It doesn't matter which one is like the gamma and which one is the epsilon. So I just have more and less. And then advent. It's a very, I was going to say very fun. I don't know. Very fun for a certain type of person. Pretty fun programming competition. During December, new problem is released each day, and then you solve it. There's a leaderboard. I didn't get on the leaderboard today. And now I'm just going over the problems. So here we loop over. This is the number of characters. And then we get the count. And if the count is greater than the count of the other type of thing, we'll add 1 to more and 0 to less, and we'll flip it if it's not. So that gives us our two values here. And then I need to then convert this to binary, or to an integer. And so this is a 1, this is a 2, this is a 4. And so I reverse over the characters. This is like my current column. I don't even know really. It's tough to come up with like very accurate variable names under pressure. But basically we have the size, or this is like the digit, I don't know. We add the size to our total if the character is a 1, and then when we process the next one, the size will be worth twice as much. So this is a simple 2 binary thing. Part 1, boom. And then I can get rid of puts in more and puts in less. Then for part 2 is much more complicated. Part 2, next you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with a full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. If you have only one number left, stop. That's the rating value. Otherwise, repeat the process with the next bit to the right. So this is a straightforward recursive function where we're passed in all our numbers. This is a toggle. We have 2 criteria, so there's some toggle. If toggle is true, we're doing one criteria. If it's false, we're doing the other. And then this is which index we're looking at. So if we only have one number, we return that number. Then this is like the processing, which is explained in the next paragraph. And then, so we filter to get some fewer number of values. And then we just recurse on the next bit to the right, which is this part. And so for this part, I'm going to basically filter all the numbers with the true criteria and filter all the numbers with the false criteria, and then multiply them together. Because if we skip ahead, to find the life support rating, multiply the oxygen generator rating by the CO2 scrubber rating. which is the life support rating. That is the answer. So if we go back up a bit, the bit criteria depends on which type of rating you want to find. To find the oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If they're equally common, keep values with a 1 in the position being considered. To find the CO2 rating, use the least common, and if they're equally common, use a 0. So this bit, that if they're equally common, you use a 1 in one case and a 0 in another case, kind of confused me, and I wasn't sure how to best represent that. So I struggled with that. Basically, I count, all right, how many, I first count how many things have a 1 in the position, and I just count, loop over the numbers and count how many S index passed in is equal to 1. And then the number of 0 is the total number minus how many 1s there are. So I thought the sort of like easiest way to handle this is basically just handle the, let's see. If they're equal, and if toggle is true, we're basically going to be doing toggle true indicates oxygen generator. Most common tied is 1. False. CO2 scrubber. Least common tied to 0. So if it's tied and toggle is true, then we get a 1, otherwise a 0. Otherwise, if it's this case, if true, then we take the most common. If 1 is more common than 0, get 1. Otherwise, if most common is 1, take 0. If 1 is more common, take 0. And let's see, do we even, I think we can get rid of this bit by just changing like one or both of these to a greater equal. Let's see. So if we're in toggle, if they're equal, we want it to return a 0 or a 1. So this should be greater equal, return a 1. Here, if they're equal, we want it to return a 0. And so, yeah. Could also do can get rid of num equals case by using so let's see, 2845944 is our answer. 2845944. So that still works. So that gets which bit that we want to filter by, and then we loop over all the nums and we filter to get the ones where the bit at that index equals the bit we're looking for. Yeah, so that is day 3. Let's look at the leaderboard. Dang. 360 and 182. Ugh. Actually, yeah, what were my times? 428 and 1210. 308. Wow. And then 1210. very close. Bummer. Oh, I tried to where do I go? How do I get to the problem? I tried to cheese day 3. I thought it was going to be just like use the one that's more common or less common. I thought that like this was going to be a super convoluted way of just saying like one of these you end up picking the 0 and the other one you end up picking the 1. And so that if you just sort the values, you end up getting the first and last. But it was not the case. So I might have wasted some time trying to do that solution. Anyway, let's does it? Yeah. 2648 450 284 5944. That is December 3rd, 2021 solution. Cool. And that's it for Advent of Code, day 3.